Hi everybody, I'm Matt Martin, a researcher at the Comparative Constitutions Project. Like many other social scientists, I'm constantly trying to capture complex concepts from messy textual data. And for years, we've all faced the same trade-off. You can have either computational efficiency or domain expertise, but not both. Today I'm showing you how our team at the CCP broke through that limitation with the segments as topics method, a framework that combines automated natural language processing with human expertise. This is fully implemented, open source, and you can start using it today. By the end of this video, you'll see how the SAT method works and exactly how to implement it for the purposes of your research. Allow me to explain the core challenge that we faced at the Comparative Constitutions Project. Our team was working with over 330 topics across national constitutions worldwide. Traditional approaches fall into two camps. First, you have pure automation. So this includes LDA, BERT topic, and other unsupervised methods. These are fast, but tend to miss crucial nuance. They might cluster, say, judicial review with court administration, just because they share legal vocabulary, without understanding the theoretical distinction between these two topics. On the other hand, you have pure manual coding, which gives you expert insight, but it's slow, doesn't scale, and introduces bias from coder fatigue. When you're analyzing constitutional texts from over 200 countries across decades of time, this approach starts to break down. The SAT method is designed to bridge this gap, combining automated efficiency with expert precision. So the setup is more straightforward than you might think. Here I have up on the screen the README file that we have on our GitHub, which explains at length each stage of both the setup and the substantive analysis in this whole method. So there are a few things that I'd like to highlight here. You'll need Python 3.9.21, at least 8 gigabytes of RAM, though 16 gigabytes is recommended, and about 5 gigabytes of storage. The system works for Mac, it works for Linux, and it works for Windows operating systems. So the installation uses Anaconda for environment management. So you create a dedicated environment, install the required packages, which are also included, and run the installer notebook. The installer notebook can be found in the main folder. So you'll notice it right here. It also comes in the form of a Jupyter notebook, making things very easy. Once you download the main folder from our GitHub repository, you can then run the installer, which will give you all of the data, all of the extra files that you need to run this on your local machine. Let's quickly take a look underneath the hood. The system here has three core components. First, we have sentence encoding. If you dive straight in, you'll notice a folder by the name of encoders. And here we have two versions of Google's Universal Sentence Encoder. Version 3 for multilingual documents and version 4 for English language documents. We use this encoder to convert text into numerical representations that capture semantic meaning. The distance between 2 points is used to measure the divergence in the meaning of those corresponding text segments. A score of 1.0 signifies identical meaning, whereas lower scores mean more divergence. If we go back, the second thing that we have is a structured corpus. So if you go into the model subfolder and CCP, you'll notice that our constitutional texts are already pre-processed, segmented, and indexed so that we can search through them instantly, as we'll do later. And lastly, if we go into the analysis subfolder, you'll see the SAT expansion pipeline. This comes in the form of a Jupyter notebook that we're going to spend much of our time doing the analysis in. And the last thing I want to highlight here before moving on is that our method is model agnostic, meaning that you can swap in different encoders as they improve. What matters is having fast, accurate semantic similarity. Now let's walk through the 4 stages of the SAT method. So as you'll notice, I've opened up the Jupyter notebook with the SAT expansion pipeline. This first piece of the notebook has a lot of helpful context and information for you to read through, but it also includes a few steps for initialization that we'll walk through very quickly to make sure that we're on the same page. So if you scroll down, you'll notice that step 1 is to load the packages and the functions. Nothing too crazy here, just some Python scripts. Now don't be concerned, this will take just a minute to make sure that everything is running properly, and once that asterisk goes away, it will show a number to effectively convey that that cell is now complete. We'll move on down to step 2, start the Python web server, which just allows some other functionalities. Step 3 is selecting and loading the models. And here you'll notice a few things. We have 4 different models, i.e. 4 different data types that we can potentially look at here. We have CCP constitutions, which is what we'll be looking at for the purpose of this example. And we've included different file types, including docx files, CSV files, and Excel files. So again, we'll click on the CCP constitutions because that's what we'll be looking at here. And then lastly, we will pass through the initialization step. Again, just give it a moment to work through, to run the cell, and after it's done, it will show a number. Just give it one moment here. All right. The first stage of the SAT method is SAT generation. So SAT generation starts with domain experts working with the system to formulate a candidate topic. So let's say we're exploring the rights and duties of parents, one of the 3 candidate topics that we review in full detail in the paper, and one that has become increasingly prevalent in today's constitutions. We'll scroll down to this cell, activate the interface, and we're going to enter in a topic key, which in our case will be parents, alongside a topic formulation, i.e. a phrase that captures the meaning of a candidate topic, which is then tested against the corpus of Constitution segments. So here we'll put the rights and duties of parents. All right, apply our choices, and then we'll run the semantic search. So what you'll notice is what the search returns are Constitution segments matching to the candidate topic formulation at or above the search threshold, which in our case is 0.63. So you can see the actual text segments and, importantly, the source document information, i.e. which Constitution they come from. So what we're going to do here is we select a small set of segments that best match the meaning of the candidate topic, which creates what we call the SAT seed set. And don't worry too much about missing relevant segments at this stage. They should reappear during the SAT expansion stage. And for our purposes, I don't have too much time to review here, so I'll take a chance to show you the built-in n-gram search feature. So if we wanted to look through these segments for a particular phrase, in our case parents, we could very easily type that in, and it filters out those segments that specifically mention the word parents. So here we'll look for a few examples to make our life easy. The care and raising of children is the right and obligation of both parents. We'll accept that. Parents have the right and the duty to raise and care for their children from the Estonian Constitution. We will accept that one. It is the right and duty of parents to nourish, educate, and protect their children. We will also accept that one. So once we have those accepted, and you can spend as much time as you want going through all of the results, all of the segments, all of the clusters, we'll move on to the SAT expansion stage. The second stage is SAT expansion, and this is where the method really shines. The seed set is used to search the corpus for additional segments that match the meaning of a candidate topic. And this represents a change from the SAT generation stage, which used the topic formulation to search the corpus. So if we run this cell here, what you'll notice is that we have our seed set, those 3 segments that we just accepted in the previous stage. If we move on to the SAT expansion interface, we'll apply our mapping and cluster thresholds, apply our choices there, and we'll run the SAT expansion process. All right. So it will take just a moment to conduct the search, and then we have the number of candidate segments here. So these search results are clustered, and both clusters and individual segments are presented to you for evaluation. So the segments you select are added to the SAT set. So what we'll do here is just select a few. And again, I'm not being super rigorous in terms of what actually counts towards this particular topic. But what I want to show is that, we select these and the unselected segments are added to the rejected set. So this process is repeated to expand the SAT set until no additional matching segments can be found. So what we'll do here is move back up to the cell. We'll run it again. We have our updated SAT size of 7 segments. We have another additional 15 segments that show up from our search, clustered into 3 clusters. So just for the purpose of this example, we'll run this again as if we didn't accept any segments for the purpose of this example, and it will tell us that the process has terminated. Please review the final set in the cell below. Stage 3 is SAT review. So as you work through the expansion process shown above, you're building a curated collection of text segments that represents your emerging topic definition. Each segment is grounded in actual corpus text, not abstract definition. And the SAT review stage is where domain expertise becomes crucial. You now have a collection of semantically related segments, but does this constitute a coherent, theoretically meaningful topic for your vocabulary? So if we run this cell here, we'll open up the SAT review interface, we'll apply our choices, and then we'll have the opportunity to review the final SAT. So let's run this quickly. So as we showed previously, we have our 7 segments, we have our 2 clusters, and similarly, we'll go through this process of accepting and rejecting the final SAT. So ultimately, you're making a judgment call. Does this segment collection represent a topic worth including in your vocabulary? And this may involve revising the segment set or reconsidering the topic's placement within the vocabulary structure. The idea being that if you wanted to, you could very well remove one of these segments from the ultimate SAT set. Theoretical knowledge and research objectives ultimately guide these decisions. And once you're done here, once you've decided which to accept and reject, you'll move on to writing the final SAT to a CSV file. All right. It will ask you to provide a label. We'll do parents. It will ask you for a description. Oftentimes, you can put the same topic formulation in an extended form. Here, we'll just enter in the rights and duties of parents once again. And we will accept review. This will export into the outputs folder, and there we are, parents final sat.csv, which should contain all of the accepted segments that we just looked at. The last stage, SAT integration, is discussed at length in the paper, but is not shown in this notebook. Ultimately, if the topic is approved, like the rights and duties of parents, the integration stage handles the implementation automatically. All segments in our final collection of segments for the parents topic were tagged with the new topic label in our corpus. In our case, the system updated the corpus index, making the new topic available for all downstream analyses. What would have taken weeks of manual annotation happened automatically once the conceptual work was complete. If you're working with large textual corpora and struggling with the automation versus expertise trade-off, we'd strongly recommend trying the SAT method. The installation documentation is thorough, and we provide active support through GitHub issues. I'd recommend starting with our example constitutional data to understand the workflow, then adapt it to your own corpus. I would personally be happy to help you prepare new data for analysis, as your corpus may not follow the same XML structure as that of the Comparative Constitutions Project. Though I should note, we include other examples in this workflow for CSV files, docx files, and Excel files too. If you implement the SAT for your work, we'd love to hear about your results. The link to the repository is in the description, along with the paper citation. Thanks so much for watching, and good luck with your research.